Hello dear students. Today we are going to discuss about some important questions of the first chapter, that is relations and functions. Okay, in that in this year in this from this chapter we are going to get two 5 marks questions in the part D. That is two 5 marks questions means 2 into 5, you're going to get 10 marks from this first chapter. Okay, in that in the one first question we are going to get this type of question, that is to prove one onto and bijective. If a function is both one onto, then this function we call it as a bijective. Okay, so let me take up the first question. State whether the function f from R to R defined by f of x is equal to 3 minus 4x is 1 onto and bijective. Okay, so here first we have to prove whether this function is 1. For this we have to take the given function as it is, that will be there in the question itself. Then we have to take up x1 comma x2 belongs to R. Then here to prove 1 always we have to start with f of x1 is equal to f of x2. Okay, f of x is 3 minus 4x. Here f of x1 means, see here, 3 minus 4x1. f of x2 means 3 minus 4x2. 3 minus 4x1 is equal to 3 minus 4x2. We have to cancel this first 3 with the 3. We are remained with minus 4x1 is equal to minus 4x2. Then in the next step, this minus 4x1 minus 4 gets cancelled. We are getting x1 is equal to x2. We have started with f of x1 is equal to f of x2. Now we got x1 is equal to x2, means the function is 1. Now we have to prove the function is onto. How we have to prove the function is onto? For that we have to take an element from in belongs to R, that is from the codomain. Okay, y belongs to R such that y is equal to f of x. F of x is given in the question. F of x means y is equal to 3 minus 4x. Now solve for x. Keep this 4x in the left hand side and shift the rest of the things to the right hand side and bring this 4 down. Into becomes division. So now x is equal to 3 minus y by 4. This belongs to R for all y belongs to R. Thus the function is onto. If the function is 1 and onto, then we say the given function is bijective. It is very important to write the function is 1, the function is onto, and the function is bijective, because even writing bijective has marks. So this is about the first question. To have a clear idea, let me say first what is this 1 function and onto. So in rough idea, 1 means there should be distinct mapping. This is the idea about 1 function. For example, suppose you are taking f of x is equal to x square as a function in the real line R to R. Okay, so here what happens is, if f of minus 1, if you see, that is minus 1 square, we are getting 1. F of 1 you see, that is 1 square, again you are getting 1. Okay, that means from minus 1 to 1, the mapping goes to the single element 1. this is not onto 1 1. This is not 1 1 function. Here no distinct mapping. From minus 1 and 1, the answer is equal to 1 only. Distinct map, if a function has a distinct map, then only we can say it is a 1 1 function. Now about onto function. Onto function means here this first set we call it as a codomain and the second set we call it as here the first set we call it as a domain and the second we call it as a codomain. Okay, here for the onto function, for every element of codomain there should be pre-image in the domain. Again I'll consider the same example, simple example, f of x is equal to x square from R to R. Okay, now we'll see here in this codomain we have the number 2 or minus 2. Okay, so now here we have minus 2, but f of x is equal to x square. Here f of x is equal to minus 2 means x square is equal to minus 2. X is square root of minus 2. Here it is not there in our real number. Here the pre-image for minus 2 is not there in the real number. Square root of minus 2, it is not a real number, it is a complex number. So for this minus 2 we don't have the pre-image. So this function is not onto. Okay, so to become onto, for every image of the codomain there should be a pre-image in the domain. Let's take up the next problem. State whether the function f from R to R defined by f of x is equal to 1 plus x square is 1 1 onto and bijective. Okay, as you all know, if a function is 1 1 and onto, then only this will be a bijective function. First, let's take up the function f of x is equal to 1 plus x square. Now, we'll see f of minus 1 is what? F of minus 1 is 1 plus x square. That means 1 plus minus 1 square, we'll get 1 plus 1 is equal to 2. But here f of 1 also, 1 plus 1 square, 1 plus 1 is equal to 2. What we got here for 2 answers, we got 2, but minus 1 is not equal to plus 1. That means, like as I told now, here for minus 1 and 1 we are having the same image as 2. Here it is not a distinct image. So this function is a not 1 1 function. This function is a not 1 1 function. Now we'll see about onto. Okay, we have to take one element from the codomain. So let us take y belongs to R. Some y belongs to R and y is equal to f of x. This is a common step in onto, proving onto. So y is equal to f of x. What is f of x is given in the question? F of x is equal to 1 plus x square. Therefore, y is equal to 1 plus x square. Now let's solve for x. So if we solve for x, we'll get x is equal to square root of y minus 1. This number always does not belong to R. As I told in the given previous example, this minus 2, it is of the form like y minus 1. It does not belong to R. That's why this function is a not onto. So if a function is not onto and not 1 1, this is not a bijective function. I hope this is clear. Now the third question, again to check whether the function is 1 1 onto and bijective. Here we have to see the given function is from n to n and it is defined as f of x is equal to x square. We are familiar to this. How we have to start here, f of x is equal to x square, and always in the 1 1 function we have to start with let x1 comma x2 belongs to the given domain, that is x1 comma x2 belongs to n and f of x1 is equal to f of x2. Here also we have to take x1 square, f of x1 is equal to f of x2 means x1 square is equal to x2 square. That means if you take the square root, x1 is equal to x2. And previously I told f of x is x square, f of x is equal to x square, it is not 1 1, but here it is 1 1 because here the considered set is natural number set. Okay, here in the natural number we don't have minus 1, so 1 will map to 1, 2 will map to 4, 3 will map to 9, and all distinct mapping. That's why here this function is a 1 1 function. Okay, now let's see about the onto. Here let y belongs to the codomain. Y is equal to f of x. Y is equal to f of x means it is a x square. If you take the square root, y is equal to square root of y. But square root of y, it is not in the domain. Okay, it does not belong to n. Therefore, this function is not onto. That means if I take some element like 2 in this codomain, is there any pre-image for this? That becomes root 2. Root 2 is not there in the natural number set. That's why it is not a onto function. A function is a 1 1, but it is not onto, then it is a not a bijective function. Here the next question is to show that the function f from r star to r star defined by f of x is equal to 1 by x is a 1 1. To show that it is a 1 1 onto and bijective. That means it is given this function is 1 1 onto and bijective. Here one extra thing is given like r star. R star is a non-zero real number. Why it is given as non-zero? Because the function is 1 by x. If it is a r, instead of r star, if it is r is given, here it includes 0, but 1 by 0 is a not defined quantity. 1 by 0 is not defined. That's why they have included r star. It is a non-zero real number. They have excluded the 0. Then this function is defined. Okay, so let's move to the problem now. Given this function f of x is equal to 1 by x, and as usual to show the 1 1 we have to start with x1 x2 belongs to r star, f of x1 is equal to f of x2. What is f of x1? 1 by x1 is equal to 1 by x2. Then obviously x1 is equal to x2. This function is 1 1. Okay. Now to prove onto, we have to take one element from the codomain. Y belongs to r star such that y is equal to f of x. Now f of x means it is given 1 by x. So solve for x. Then x is equal to 1 by y. Here it belongs to r star. Because r star, it is a non-zero quantity. 1 by y is defined. X equal to 1 by y belongs to r star for all y belongs to r, and therefore this f is onto. A function is 1, 1, a function is onto, which implies the given function is bijective.